quizzes because you know these test statistics is going to be a lot harder later today or tomorrow or the next day, whenever you take it. So I don't know if that's what you want to do. If you for review is, I'll give you some scenarios. What should be the test you pick? What should be hypotheses you should use? Or, as Brandon has another question, we can answer that.
It's like a really chi-square test.
Yes, because I think so. Because what is chi-square? What do we test with chi-square? Standard deviation, right? So good chance, yeah, it'll be on there. Okay?
I was doing like the 10.5 distribution reviews, and there was like a chi-square one, and they didn't, like in the back of the book, they don't square like your standard deviation and your like both standard deviation. Are you supposed to?
It depends. So is it asking for, so if it's a confidence interval, is it asking for the standard deviation or is it asking for the variance? So it depends on what they're asking. So they might or they might not. Or if they give you the variance, you don't need to square the variance. If they give you the standard deviation, you need to square that.
Okay.
So you got to be very clear on their wording. Is it about the variance or the standard deviation? So the variance is the standard deviation squared. So you don't need to square it again if they give you the variance. Yeah.
I know you talked about this a minute ago, but here completely. So for like the names of the test, you have to like the one sample or like two sample independent test.
Yeah, two sample independent versus two sample paired versus one sample T versus one sample Z versus two sample proportion test Z, whatever they are. Okay? So here's what I will do, just so you know. Not that anybody would ever make a mistake on what kind of test to make. But if you're consistent, you picked a one sample Z and it should have been a one sample T. And so therefore your test statistic is going to be wrong. So you're not going to get credit for your test statistic. But if, so here's one thing that people do. They say it's a T statistic and then they use norm S dis for the p-value. Well, you're going to get the p-value wrong. But based on the p-value that you got, even if it's wrong, now if you got a p-value of 0.10 and you should have gotten a p-value of 0.2, that's going to affect your decision, okay? So it may have been that you were supposed to reject, but because you got the wrong p-value, you said do not reject, and then you said there's not a difference. I'm going to give you credit as long as you're consistent, okay? So you can get credit even if you do it wrong. You're not going to get as much credit as if you pick the right, not only the right T or Z test, but the p-value as well. So don't mix up norm S dis with T dist. If it's a T, use T. If it's a norm, use norm. If it's a chi, use chi. Okay? And so you are going to get your formula sheets on the test, but I still want the p-value. Okay? If you want to do it with the classical method because that's easier for you, I don't have a problem with that, but I want the p-value. I want to know what the p-value is. And if you want to use the classical method to help you know reject or do not reject, that's fine, but I still want to know what the p-value is. And use the correct, don't use the table on that. Use the computer on that. Now you can if you want to double check yourself, but use the computer.
So I was a little confused. When we're taking the test and we need to determine whether it's a z-test, t-test, or chi-square, do we need to write down specifically that it's a
yeah, so here's why this comes up. In the past I say, what is the test statistic? And some people are like, it's a T, it's a Z. And so I've decided to change that into two questions. What is the name of the test statistic? It's a T, it's a two sample T, paired, independent, whatever you want to put there.
Okay.
And then I say, what is the value of the test statistic? So it just makes it easier because it drives me crazy when I say, what is the test statistic? And they're like, it's a T. And I'm like, thanks. What's the value, okay? So I'm going to ask you both questions. And that's why, just for clarity. So when I say what is, I don't get, yeah, it's a T, but what's the value, okay?
Yeah, I was wondering if we could do an example on a two-tailed type 2 error test.
Two-tailed type 2 error test.
Yeah.
Okay, do you have one?
Yeah, it's from the review on chapter 10.
Chapter 10 review?
Yep.
Okay.
It's number 18.
10 point what?
So it's just the chapter, so chapter review 10.6, number 18.
Chapter review 10.6. Oh, by the way, while I'm pulling that up, 10.6. Where's it, the review?
It's page 522.
532?
522. Or 23, 24 actually. That's
522, number 24. Really quickly,
number
I
18.
don't want to digress too much into this. But I did want to show you just a couple other things. 2012 election info, okay? I did this back in 2012 because I wanted to see how Ohio was. Now, the interesting thing is there are lots of different changes. So remember that was Obama and, oh, this is an interesting map. This is the United States by population, okay? You'll remember there was this graph that said, oh look, most of America is red. Just remember, nobody lives here. Okay? So you're making a bunch of cows red. Okay, fine. That's how we got the red states, blue states. But if you look at the map by population, there's a lot more blue in it. Okay? So anyway, what I wanted to point out here really quickly was, you know, some polls in Ohio had Mitt Romney winning. See? So some of them were wrong. So anyway, that's kind of interesting to see. Anything else? So you can track. You guys want to track this? Are any of you interested in tracking this just for fun? So I'll post it or I won't post it. Who would like it posted as an announcement? Okay. So I'll go ahead and post that. So this is what I wasted way too much time doing that last night. Anyway, it's not often. You guys are lucky because it takes 4 years to get a census, and we're having one tomorrow. Okay. Is there going to be a margin of error on tonight's results? No. Why not? There may be errors, but there's no margin of error.
This is a population.
Because it's a census. There's no margin of error on a census. If you don't vote, you don't count. Okay? So if you want to complain about whoever the winner is, and you don't care who the winner is, because you think there's no difference, vote for Jill Stein, vote for Gary Johnson, vote for Evan McMullen. Okay? Or Darrell Castle, or
Who are you voting for?
who am I voting for? I don't know. I'm being recorded, so I don't want to be too partisan. But yeah, I don't like the two at the top of the ticket, of either ticket, I'll say that. So, anyway, yeah, vote third party, that's a good thing. And don't let anybody tell you that's a wasted vote. Send a message to the parties that they have wasted candidates, and they're not deserving of your vote. That's what I would say. Okay, what was the number again?
Alright, it's 7 on 520.
7. This is on page 523.
520, sorry.
Page 520.
7, yeah.
Page 520. 520, number 7. Okay, number 7 says, for you. Test the null hypothesis P equals 0.45 versus the alternative hypothesis P does not equal 0.45. Okay. Simple random sample n equals 500. Individually we got x equals 245 successes are observed. So part A says, what does it mean to make a
reject when the alternate's true.
Do not reject what?
The null.
The null, and in this case, the null is c equals 0.45 when the alternate is true, which means p does not equal 0.45. Okay? All right. That was part A. Part B says, if the researcher decides to test this at alpha equals 0.10, level of significance, compute the probability of a type 2 error given that the true population is 0.49 equals 0.49. Okay? So how do we do this one?
Your level of significance equals your probability of rejection minus something. So, or something.
Aren't we going to do point?
Okay, where's the first step? Do you guys need a hint?
Yeah.
Do a normal distribution.
WWRD.
Oh,
Okay, draw a picture. That should be your very first step on these every single time. Now, well, if you're doing this on this is actually a computer question because there's a lot of calculations involved. So if you want to draw it on there, I know you can draw it on your scratch paper. I'm obviously not going to see that, so I'm not going to require a picture. However, if you want to draw it on here, you can insert. This doesn't have a good drawing tool. Never mind. You're gonna have to draw it on paper. I thought there was a way to draw. But if you open up Paintbrush, I'm gonna get an email saying you were cheating. Don't do that. I don't want an email. I would ignore that, but they're really sticky about that. So anyway, don't open Paintbrush. Okay. So what do I label my picture?
Zeros.
Nope.
0.45.
We're going to say that P equals 0.45. Okay? This one we don't want to do a standard normal curve. We want the actual normal curve. Okay? Now what? What else do I need on my picture?
Reject regions.
What'd you say?
Reject regions.
I need the rejection regions. Okay? So if my alpha equals 0.10, how much is in this case? So alpha over 2 equals 0.05, and over here, alpha over 2 equals 0.05. So we add those two up, we get our total alpha, our type 1 error. Okay? Now what? What?
We have to find the z-scores.
Okay, so we're trying to find these two values, right? Okay, so to find those, Cassidy said we need our z-scores. What's that formula? P hat minus P over square root of PQ over N, okay? Okay? All right, so now what?
So drawing P hat 0.49 minus 0.45.
So you're skipping a step.
First one.
245 over 5.
Do we know what Z is? Can we find out?
Yeah.
We can find out. How do we find out what Z is?
Look on the
Look on your chart.
1.92. Awesome.
Okay, so remember here, by the way, okay, so I got my Z chart pulled up here. Which table am I looking at? It doesn't matter. What'd you say?
Hypothesis testing critical value.
It's hypothesis testing critical values. We're doing a two-tailed test, okay? My significance level is 0.10. This gives me the Z. So Z is going to equal plus or minus 1.645. Now, just FYI, let's just look at these. On the two-tailed tests, if I had looked over here, If my alpha is 0.10, my confidence level is 90%, I got 1.645. Those are the exact same values if you're doing a two-tailed test. So if you're doing a two-tailed test, these are exactly the same. If it's one-tailed, no, not necessarily. Okay? So, yeah. Anyway, this does have the plus and minus, this doesn't, so this is probably good to remind you of that. Okay, so now, so I do know what Z is. Z is plus or minus 1.645 equals P hat. Do we know P hat? No? We're going to call it P reject. Okay? Minus, do we know P? P is 0.45. We're going to divide that by square root of 0.45 times 0.55 divided by 500. Okay? Now I've got two values I'm going to need here, right? So essentially, if I do a little bit of math, I'm going to take that, I'm going to multiply it by the denominator, and I'm going to add that, right? Okay? So in this case, okay, so I'm going to need my P reject. I decided I like that. Okay, so the P reject is going to be 1.645 times the square root of 0.45 times 0.55 divided by 500. And then I'm going to add 0.45, right? Both sides. So I did all that algebra in my head there. But, okay. Okay, so I got a value of 0.486. Now I'm going to do the same thing here, but this time I'm going to change that plus to a minus. And so I've got my P reject over here, except for I wrote it backwards, didn't I? So this is really on the left, and this one's on the right. Because I do that all the time. Okay, so this value here becomes 0.4134, and this value here becomes 0.4866, right? Okay? Now what?
Do it all over again.
Do it all over again, but what's the difference?
1.9.
Okay, so we're going to use this equation again. But P is no longer, we were using that number, so we're not using that number anymore. What are we going to use? We're going to use the probability of a type 2 given that P equals 0.49. Now 0.49 on my graph is just barely in my rejection region, right? It's about right here. Okay? So that value is 0.49. So what should I be doing here? Draw a new curve, right? Okay, the new curve with the mean here, and it's going to go like this, and like that, right? Okay, now what? Okay, I'm going to extend my rejection region up here, okay? And I'm going to shade everything between the two rejection regions in this case. Okay? So that red area is the probability of the type 2 error. Does that make sense?
How did you decide to draw the second graph on the right?
Why did I draw on the right? Why is that? Because we said that the new probability is not 0.45. We don't believe that anymore. We believe it's 0.49. Okay? All right, so now, I've got a new normal curve with the mean right here. Okay? So I'm looking for this area. How do I find that area? We're going to use this equation again, right? We're going to use it 2 more times. 4 equations. Where's the equation on this? Good question. Okay? All right, so I'm gonna use it again. What are the two equations?
The two rejection values.
Two rejection regions, so I'll use the 0.4134 minus, Tim, you take it away, you seem like you know what you're doing.
Yes, now, but wait till I get to the test, minus 0.49.
0.49 over,
The square root of the 0.49 times 0.51 should still be over 500.
okay? And what's the other equation I need?
Same thing, just change to 0.4866.
866 minus 0.49 all over square root of 49 times 0.51 all over 500. Let's do those really quickly. Okay, so this is going to give me my z-score. This is going to be this minus 0.49 equals the square root of 0.49 times 0.51 divided by 500. We're going to divide that. We'll do it again here. We're going to get our z-scores. This is going to be that number divided by that number, which is negative 3.42 and negative 0.15. What are we going to do next?
Is it known as this?
We're going to get our p-values, right? Is it norm as this? Yes, we use the normal distribution. Norm as this and that. And that. And then what are we going to do? You add them? So probability of your type 2 error here is we're going to subtract the bigger number minus the smaller number. We don't want a negative p-value, right? So the probability of the type 2 error is that. What is the power? 1 minus that. So does this test have very good power, would you say? No. So as I've been thinking about this, I think what I'm going to do, since Utah is sort of a battleground best state, I'm going to say, I'm going to pull up this, I'll pull up Evan McMullen, ignore Evan McMullen, we'll do the probability of a type 2 error. We're actually going to know what the real population is going to be. So I'll write it here now, but you're not going to know the results until tonight. Probability of a type 2 error given whatever the true population is. We're going to compare that with what the sample was. Okay? So you generally would like your power to be above 80%. Of course, you don't have control over that, especially in a close election like this.
So if it's above 80, it's
If above it's 80, that's pretty good. Okay? All right, study hard and do well. It's going to be a fun test.